Okay, good afternoon, students. Um, we will continue our study. Before we already learned how to differentiate integral to equation of this position, velocity, and acceleration, right? Yeah. So if you have position equation or displacement equation, you have to differential to have velocity and then differential again to have acceleration. Vice versa, if you have acceleration, you have to integrate to get velocity, and you have to integrate to get position displacement. Today, I would like to discuss about the um, motion, yeah, vertical motion under gravity acceleration. Yeah, so our topic today is vertical motion under gravity acceleration. Yeah, I will use whiteboard instead. Yeah, yeah. Okay, so the equation that we already know in the accelerated motion, yeah, the yeah, this is the title. Yeah, we will learn about this one: vertical motion under gravity acceleration. Okay, yeah, it actually is as the same as the accelerated motion, yeah, because we have acceleration of gravity. Yeah, if you look at the equation in the acceleration motion, the first is how to find the distance, right? So in the accelerated motion, first we know the distance equals to initial velocity times t, a half at square, right? Plus a half at square. And then final velocity equals to initial velocity plus acceleration multiplied with time, right? The third is final velocity square will be equals to, what is the equation? Do you know? Final velocity square will be equals to initial velocity square plus 2 times acceleration times distance, yeah, or displacement, right? So um, parallel to this, yeah, in motion under gravity acceleration, we just substitute the acceleration into gravity, yeah. But first, that we have to know this is a factor, so you have to uh, differentiate the sign of plus and minus. Yeah. So for example, if you have a vertical up motion, yeah, goes to up, that means the initial velocity is positive, right? The initial velocity is positive and the acceleration is negative because the gravitational acceleration directed downward, yeah, so it's negative, right? If you have a vertical downwards motion, yeah, so initial velocity is negative, yeah, initial velocity is negative and the gravitational also negative. Okay, so this is according to the direction, yeah, negative positive, right? Now you can change the substitute the unit here or the alphabet here. S is will be equals to the height that you traveled, yeah, that the particles traveled. Initial velocity, let's say this is for vertical up, yeah, positive, times t minus a half gt square, right? Gt square. and final velocity will be equals to initial velocity, yeah, let's say this is going up also, minus gravitation multiplied with time, right? The third is velocity square is equals to initial velocity square minus 2 times gravitational acceleration times height, yeah. So for vertical motion under gravitation, we substitute the coefficient coefficient of the uh, equation, yeah. The distance will be the height because it's in meters. Velocity is still velocity, yeah. Initial velocity is still use u. Acceleration will be replaced by gravitational and with sign minus because it's downward, yeah. All right. Any question?
Wait, sir. Why
Hmm?
why is the I just want to know like the v squared is equals to u squared plus 2as.
Mm-hmm.
Uh why is it u squared and what is s?
As distance, yeah.
Oh,
From this box equation, s is the distance traveled or displacement, right? Okay, so if this equation, the second equation used, if you know the acceleration, the time, and initial speed, yeah. We use the third equation if you don't know the time, you only know the initial speed, the acceleration, and the distance is traveled, right? Okay, but how do you get this equation? Yeah, actually you can substitute time in the equation s, or u in the equation v here, right? There is also another equation actually, yeah. It's from the graphic, yeah. A half of final velocity plus initial velocity multiply with time. Yeah, if I'm not mistaken, this is time. Yeah, divided by, wait, a half. Uh, yeah, that's right. This is the equation. Yeah, because from the graphic of displacement and time, so you need to find the sorry, from the velocity and time graphic, right? Velocity and time graphic, you just need to find the area of the graphic, right? To find the distance. If it's look like the trapezoid, so that means you just find the formula for trapezoid. Okay. Any question again? No, yeah. Okay. Let's see example of questions. Can I clear this, or you want to take a note? Hmm?
No, sir.
Yeah, you already know, right?
Yes.
Okay. Let's see the example. Example of equation. That's fine. Right. Uh, question number. Yeah. Question number 5. Yeah. Let's see question number 5. Yeah. From the question number 5, we can see that Nathan hits the ball. Wait, I'm going to zoom it first. Yeah. Yeah. Nathan hits the tennis ball straight up into the air from the height of 1.25 meters above the ground. The ball hits the ground after 2.5 seconds. find the speed Nathan hits the ball, the greatest height above the ground reached by the ball, the speed the ball hits the ground, how high the ball bounces if it is loses 0.2 of its speed on hitting the ground. Is your answer to part I likely to be an over or underestimate given that you have ignored air resistance? Okay, let's see the first question first, yeah? The speed Nathan hits the ball. So, how do you answer that? What is known here? What units or what quantity that is known here?
Time and
Huh?
height. Distance.
Yeah. First, we know the height, right? We know the position. It's 1.25 above the ground, 1.25 meters. And then we know the time that is needed to be on the ground, yeah. Total time. Let's say total time from the first moving until hits the ground. 2.5 second. What else known here? Hmm? What else known here? Of course, the acceleration, gravitational acceleration. Let's use 10, yeah? So it's minus 10, right? Meter per second square, right? And then, what is the question for I? What is the question? Hmm? Hello? What is the question for I? Hmm? The speed hits the ball, so that means, is it initial speed or final speed?
I know.
I know.
Huh? The speed final is hits the ground, not hits when the Nathan hits the ball is the initial, right? Right?
Yeah.
Yes.
Final condition is when the ball hits the ground. If Nathan hits the ball is initial condition, right? So it is asking about initial speed. Now it is asking about initial speed. So what formula will you use if you know distance, time, gravitational acceleration? You will find u. What formula will you use? What do you think? Hmm? H equals to u times t minus, yeah, I think let's to make it so that's it is not wrong, just make it 10, yeah, not minus 10, because it will be minus with minus again there is positive, yeah. 10 minus a half gt square, right? Minus a half gt square. Now the final condition of the ball is the distance is, do you understand? So when the ball is first hits, it goes up and then back when it touched the ground here. So the final condition from the starting condition is this distance, right? Equal to 1.25. Yeah. So the height is 1.25 meters, right? Can you see that? That's clear first.
Sir, we're
Yes.
finding you, right?
Yes.
Shouldn't it be plus instead of minus?
Which one?
UT plus.
Yeah, that's what I already mentioned, right? In the vertical motion, the gravitational downward. So we use minus g, right? Yeah, that's if you use in the equation minus a half gt square. So here the gravitation use positive 10. But if you use here positive, so that means you have to put negative here, right? Right? Am I right? Hello. Hi, hi.
Yes.
Mhm. Okay, continue. Yeah. Now, the distance is traveled is minus 1.25. Agree? Agree or not? The initial speed is asked. The time is 2.5, right? Minus, let's say a half times 10 is 5, yeah? 5 t square, so it's 2.5 square. Okay? Do you understand? Why is the height minus 1.25? Hmm? Why is the height here minus 1.25 in the equations?
No, sir. I don't understand.
Because
Please
it goes
explain.
down.
That's right, because it goes down. So if you look from the diagram illustration here, this is the ball, hits by the Nathan, goes up, and then uh, fall back again into the ground. So the condition from the starting point here into the ending point here is this distance, right? The distance is 1.25 above the ground. So this ball displacement is 1.25, but it's under the starting point. That's why it's minus. Okay, minus 1.25. Now you do the multiplication and then you change the position of 5, so you can get u, yeah, minus 1.25, right? Plus, what is 5 times 2.5 square? How much is it? Let's use calculators then. 5 times 2.5 square. 31.25, yeah. 31.25. Okay, equals to 2.5 u, yeah. U times 2.5, it still means 2.5 u. Okay, now added 1.25 with 21.25, that will be 30, yeah. Yeah, so let's see the equation here. That will be 30 equals to 2.5 u, right? So u equals to how much? 30 divided by 2.5,
Well,
12. So the initial speed is 12 meter per second, and because it is positive, so it's makes sense, yeah, because the Nathan hits the ball straight up, goes up. So it makes sense. If you have the answers for you is negative, this doesn't add up. Yeah, something's that's wrong maybe. Okay, any questions? If you don't understand, please ask. Yeah. So you, after this class, you did not bring any confusing. How many teachers there will be micro teaching today?
Uh, 2.
2, yeah. So that means you'll be here until 5 then. Would be, yeah.
I think it might be 30 minutes each, but hopefully not.
Oh, okay. Yeah, I think I have also to watch that micro teaching. Mr. Gabriel asked me also. Any questions?
I don't think so.
Okay. Can you continue next question, or are you still taking note for this one?
You can continue, sir.
Okay. Sorry, I heard. No, yeah, no question, yeah. Okay, continue. Yeah. Next question 5II. How do we find the greatest height above the ground reached by the ball? So the illustration that I already draw is it goes up, right, and then falls back again to the ground. Now, what is the highest position above the ground? So this is asking this distance, right? Asking that distance. So how do you get it? What is the condition of the particle or of the ball when it reached the highest position? If something goes up, you throw it up in the highest position. What is the condition it's require? Do you know? The final speed in the highest position has to be, huh? The final speed here has to be 0,
0,
right?
sir.
Yeah, that's right. It should be 0. So yeah, you know this final speed is 0. Yeah, this speed is 0, and then you have to find what is the height from the starting point into the final speed 0 here. After you have that, you can add from the height of the above the ground 1.25. So that is the highest position of the ball. Yeah. Now, how do you find the height maximum when it is 0? You can use the equations. The third equation here, v square equals to u square, and then plus 2 times a times
S.
s. Yeah. Substitute a with gravitational. Substitute s with h that we want to find. Yeah. Now v square here is 0. Yeah, because it's in maximum height. Yeah, 0. Initial velocity that we already find in the AI is 12. Yeah, 12 square, and then minus 2 times acceleration equals to 10. Yeah, height is what we want to find. Yeah, so s we substitute with height. Okay, according to this equation, so minus 20h will be moved into left side with very positive 20h, right? 20h, 20 times h equals to 144. 12 square is 144. So the height from the starting point into the maximum position is 144 divided by 20. How much is it?
7.2.
That's right, 7.2 meters, right? Is it the final answer? No, not yet, because it is asking above the ground, yeah? The greatest height above the ground. So 7.2 is from the starting point to the maximum height. What about the position above the ground? That will be,
1.25.
yeah, you just add it with the 1.25. Yeah, 7.2 plus 1.25, right? How much? Uh, 8.45, yeah. 8.45 meters, right? 8.45 meters. Any questions? Continue? Yeah, continue, yeah?
Yes, sir.
Okay. Question number 3. Do you want to try it? What is the speed of the ball when it hits the ground? So this is asking about final velocity, yeah? Final velocity. Thunder. Is it rain in your house?
No, sir.
No, yeah.
Nope, not at
My
all.
house is raining with thunder. Anyone has answer? I. What formula we will use?
The v squared.
That's right. And then
V squared equals u squared plus 2as.
mhm. So how much is the answer? V squared equals to u squared plus 2as. Okay, so v square equals to how much? U square? 12 square, right?
Yes, sir.
Yeah, 12 square. And then
Plus 2,
plus 2.
10.
Huh? how much is the A acceleration? Gravitational acceleration is
10
minus 10. Yeah, don't
minus
forget minus 10, yeah, because it's directed downward. And S, how much is the displacement?
That's the maximum height, I see.
No, because it say hits the ground. If it say hits the ground, so the displacement when it is hits the ground from the starting point to when it hits the ground, not the maximum.
so 7.2 plus 1.25.
No, minus 1.25.
Uh,
Okay, because the the condition starting and the condition after it hits the ground is this displacement, right? So it's minus because it's displacement is downward. Yeah. So multiply it, calculate 144 plus how much?
25.
Hmm?
25.
25, yeah.
Yes.
Okay. So p square equals to
169.
169. That means equals to 13
13.
meter per second. Yeah, 13 meter per second. Continue.
Yes, I continue.
Okay. Number 4, IV 4. How high the ball bounces if it is loses 0.2 of its speed on hitting the ground. Yeah. So if we illustrate it, yeah, the ball is hitting the ground. When it hits the ground, it's bounced back again. Yeah, bounce back, but it losing its speed when it hit the ground is 0.2, loses 0.2. Now the question is how high is after bouncing the first with the ground. This is us. Yeah, how high? If it is lose 0.2 of its speed, so what is its speed when it is leaving the ground? That means 0.8 from 13, right? 13 meter per second. Am I right? Because the speed when it reaches the ground is 13 meter per second. So if it is loses 0.2, that will have another the rest is 0.8, right? So the initial speed when it bounces is 0.8 times 13. How much is it? 10.4, yeah. So now it has speed 10.4 meter per second going up. Yeah. Now the question is the highest high. Yeah, how high? That means at the highest maximum or the highest height here, the velocity is 0, right? You can use the formula v square again. V square equals to u square plus 2 times acceleration times height. This is what we want to find, height, yeah. The v square is 0, yeah. The u square is 10.4 meter per second, yeah. Square it minus acceleration is gravity 10, so it's 20 times height, yeah. 20 height, move it into the left side, becomes positive. 20 height equals to, how much is 10.4 square?
Uh, 108.16.
108.16, that's right. So 108.16 divided by 20, that will be the height when after the bounce. How much? 108.16 divided by 20.
5.4.
5.4, yeah. Is it?
Yes, sir, if you round it up. You round it up like
Oh,
5.41.
wait, yeah. Yeah, 5.40108, yeah. So 5 point, let's make it 3 significant figure then. 5.41 meters, yeah. 3 significant figures, yeah.
Sir,
Yes,
I have a question. At
yes.
the start for the 0.8 times 13,
Mm-hmm.
when we times 0.8 with 13?
Yeah, because it loses 0.2. So if you lose 0.2, the rest is 0.8, right? You still have 0.8, right? If you have one bread, for example, you have a bread, one bread, 0.2 of the bread is given to other person. So how much you have the bread,
Oh, you see.
right?
Yeah,
0.8 of the bread, right?
yes, sir.
Uh, okay, continue. I think number 5, you don't have to answer this one. Maybe you can have your practice to answer it. Number, do you still want to take note for this
Already.
already? Yeah. All right. Now let's have a, you answer it for number 8. Number 8. Oops, sorry. Yeah.
Sir,
Yes.
later submit.
Yeah. Submit. Yeah. Number 8. answer it in the piece of paper or in the Word, and then submit it in the Microsoft Teams. I'll create the assignment. Yeah, number 8 only, because it's already 2:46. Sorry, where is the question again? Okay. Okay, there. I already sent the assignment, posted the assignment. Wait, I'm going to turn on the light first. Do you have the questions, students? I mean, I want to stop the sharing because I think
Number 8 and 9 Rese.
only number 8 only.
Oh, okay.
Okay. Already? Can I stop the share?
I think.
Already, yeah? Others? How about others? You have already the question, yeah? Okay, I will stop the share because I think some of the teachers already want to have the micro teaching. Hello, Miss Lenny.
Halo, Sir.
Yeah.
Yes, sir.
Ya
It's still
selesai ya?
it's still recording.
Oh, sorry. I'm still recording.